Okay, so let's start today's class. I welcome you back again into today's tutorial where we're going to be focusing on a understanding basic and networking concepts. So inside this course, what are we going to be focusing? The first thing here, we're going to know what is a networking. So we're going to know what is a computer networking, and we're going to know the types of networks. We're going to know the benefit of networks, and you're going to know the different various type of the network devices. So let's dive into what we have. The first thing here says what is a computer networking. So here, when we're talking about a computer networking is the process of interconnecting two or more computing devices together for the purpose of sharing information and the resources. So basically, when we're talking about a networking, so anytime we are hearing networking, what we must put in mind is that the networking is the process of a interconnect two or more computing devices together. So in a scenario that we are connecting two or more computing devices together, that is what networking is. So here says a computing, when you're talking about a computing device, it is not only our computer. So anytime you are hearing about a computing device is not only your laptop or your PC. So when we're talking about a computing device is anything, any devices that we can assign IP address to. Those are what we call a computing device. So here now say that networking is the process of interconnecting two or more computing devices together. It can be your PC, it can be your server, it can be your printer, it can be your phone. So in the process that we are connecting them together, that is what a networking means. And when we are connecting these devices together, there must be the purpose that we are connecting them together for. Here it says that for the purpose of sharing information and the resources. So anytime we want to share the information and the resources, that is the main point of we connecting two or more computing devices together. So that is what a networking means. Networking is the process of interconnecting two or more computing devices together for the purpose of sharing information and resources. So the next thing here is the benefit of a network. The first benefit of a network is a information sharing, and the second benefit is a resources sharing. So when we're talking about information sharing, what are the example of a information sharing? We have files and documents, and we have video conferencing streaming. Those are the example of what information sharing is. So for instance, maybe we have a two system on the network and we want a particular file, we want to share it from system A to system B. We can actually connect the two systems together where we achieve networking, and when we connect the two systems together, we'll be able to share the files from the system A to the system B. The second one say is a video conferencing streaming. So for instance, imagine you are working for your organization and you are the senior manager of the organization. Maybe you want to pass information to all the employees. You don't need to be going to each room to another offices before you can pass the information. You can actually make use of what we call a Zoom. You can make use of Zoom and everybody will be seeing you and you'll be passing the information. Or we can make use of a WhatsApp video calls and everybody will be seeing you and you'll be passing the information. So that's another example of what a networking is, another benefit of a network under video conferencing streaming. So another example is when the president of a nation, imagine the president of Nigeria wants to pass information to everyone. Once the president is passing the information, we can use what we call a radio, through radio, and everybody from wherever they are, they will be able to be listening to the information. So for you to be able to listen from the information that a president is passing in another state, that is the benefit of a network. So the second one now says a resources sharing. So when we're talking about this resources sharing, example is the software and the hardware. So as we all know what software is, Software is something that we can see and we cannot touch. Hardware is something that we can see and we can touch. Example of a software is our applications. Those are what software is. Antivirus. Example of hardware, it can be your cable, it can be your network cable, it can be your hub, it can be your switch. So those are the example of hardware and example of a software. So when we're now talking about this resources sharing, in which way does a resources sharing give us, in which way do we have a software under what we're talking about a resources sharing? So for example, let's assume I'm working for a organization, and when I'm working for an organization and I have like I have like 10,000 PC on the network, maybe there is a need for me to install antivirus on each computer on the network. You know that if I'm doing it in a manual way, I'm going from one system to another, it's going to be giving me a tough time when we have like thousands of PC on the network. So you can make use of a server to deploy that software on each system, and all the system is going to get a particular software within a minute. Different from when you are going to each system on the network to install the software manually. So when we're talking about hardware as well, what's the benefit of hardware? So imagine I want to share a resources. Maybe I go to, for instance, let me make this one as an example. If you goes to a bank, if you goes to bank and you want to withdraw some money, before you can withdraw the money, you must have your ATM card. So that ATM card is first under a hardware for you to be able to access that particular information and you withdraw your money outside. If the ATM card is not with you, sometimes it might give you a tough time before you can get the money. So your ATM card falls under what a hardware, so for you to be able to withdraw that particular money. So those are the benefits of what computer networking is. The first benefit is the information sharing, and the second here is the resources and sharing. So the next thing we'll be talking about now here is a network diagram. So when you're talking about a network, how does a network looks like? So here is a diagram of what a network looks like when we have a router connected to switch, and this router connected to another wireless router. So people on the people on the switch use cable to connect to each other, and people on the Wi-Fi use wireless to connect to each other. So when we have this network like this, people on the Wi-Fi will still be able to communicate to people on the cable. So people using a wireless will still be able to communicate to people that they are connected with cable. So that this is what a diagram of what a network is. So the next thing we're talking about is the types of network. So when we're now talking about this network, we have different types. The first one here is a LAN. LAN stands from a local area network. And the second one here is a WLAN. We start from a wireless local area network. And the third one here is a VLAN. We stand from virtual local area network. Fourth one is a WAN. We start from a wide area network. And the last one here is a VPN. We start from a virtual private network. So let's continue to know more about all these type of network. So when we're talking about a LAN, as we all know that LAN starts from a local area network. So what is the function of a LAN? Here says that a LAN is a type of network that is within a building and it is wired. So anytime you are hearing about LAN, what I want you to put in mind is that in a LAN is type of a connectivity that is within the same building and it is wired. So when we have a connection of system on one building and they use cable to connect them together, that is what a LAN is. So here is an example of what LAN looks like. When we have a switch, inside that switch, we have a lot of system connected to this switch with cable. That is what a LAN is. Here now says that what type of cable are they going to be using to connect? They're going to be using category cable. So category cable will be used to connect all the PC to a network switch. So here is a switch, and all the systems going to make use of what we call the category cable to connect to each other. So that's what a LAN is. When we connect a system together in the same building and we use cable to connect them together, that is what a LAN. So the second type of network, which is a WLAN. WLAN stands from a wireless local area network. So what's the function of a WLAN? Here says that WLAN is a wireless computer network. It uses RF, which stands from a radio frequency, to allow all the devices to communicate with each other wirelessly. So basically, when we're talking about a WLAN and LAN, they are the same thing. But the main difference between WLAN and LAN is that LAN use cable and WLAN is a wireless. So when we're talking about a WLAN is a wireless computer network which use RF, which is a radio frequency, to allow all the devices to communicate with each other wirelessly. So like what I explained to you, LAN and WLAN, they are the same thing. But the main difference between LAN and WLAN is that LAN uses cable and a WLAN, it is wireless. So when LAN use cable, which means that anytime I'm sending information to other system, the information will be passing through the cable. But inside this WLAN, what WLAN use is what we call RF, which stands from a radio frequency. This radio frequency is going to allow all devices to communicate with each other wirelessly. So here is what a WLAN looks like when we have a wireless router and we have a lot of systems connected to the wireless router. So what this guy will be using to be talking to this guy is what they call a radio frequency. So here now says that a wireless router can also be used to set up a WLAN. So when we're talking about this WLAN, anytime you want to set up a WLAN, we can use a wireless router, or we use a WAP, which stands from a wireless access point. It's either you have a access point or you have a wireless router. So you can use all those guys to set up a WLAN. The next thing here is a VLAN. When we're talking about VLAN is a virtual local area network. That is the full meaning of a full form of a VLAN. Here now says that in a VLAN is a type of network used to segment network user from different departments. So when we're talking about a VLAN is a type of network that we use to segment. For instance, if we have a system connected on a LAN, all the system will be able to communicate to each other, which means that a system connected together on a LAN, there's no privacy and there's no security on it. Because everything that the system A is doing, system B will be seeing it. If system A want to send the information that system B shouldn't see, they will be able to see it on a LAN. But in a scenario that you want to implement a privacy on the network, what we'll use is what they call a VLAN. So I can implement a VLAN on the network so that system on a class A will not be able to see system on a class B. So that's what function of a VLAN is. So here says VLAN is a type of network used to segment. Segment is when you are now putting them in different departments. You are dividing them. Used to segment network user from different departments. So for instance, maybe I'm working for organization and I have an HR, I have sales, and I have ICT. I need to implement VLAN on it so that whatever sales is doing, ICT is not going to be seeing it. So here is a diagram of what a VLAN looks like. When we have a first system on the network, and we have the first one, which is the engineer PC1, and the second system is the engineer PC2. Third system is the sales PC1, and the second system is the sales PC2. So this engineer PC1 here, they can only talk to themselves. This sales as well can only talk to themselves, but this says they cannot talk to engineer PCs again because we have already implemented VLAN on it. We have already put these two systems in one VLAN and we put these two systems in another VLAN. Here says that PC from different VLAN, PC from different departments are not allowed to access each other. So when we have a system in a different department, there is no way they will be able to talk to themselves. Only system in the same department can talk to themselves. So the next thing we'll be talking about here will be WAN. Before we go to the last one, there's a one that is omitted here, which is a WAN. WAN is omitted before we go to VPN. So let me explain what a WAN is. When we're talking about WAN, WAN stands from a wide area network. So what's the function of a WAN? A WAN is a connection of a multiple LAN. So in a scenario that we have a lot of LANs, maybe we have a LAN in Abuja, and we have another LAN in Lagos, and we have another LAN in Port Harcourt. But we now want that three LANs to be able to communicate to themselves on the internet. That is what we call a WAN. So WAN is a connection of a multiple LAN. So when we have a LAN in different locations and we want them to be able to communicate together, that is what a wide area network is. So the next one here is a VPN, which stands from a virtual private network. So what's the function of a VPN? Here says VPN is a type of network used to connect a company's multiple branch offices to their head office or allow some remote staff to work from home. So basically, when we're talking about this VPN, imagine we are working for organization and the organization has a head office in one location and they has branch office in another location. When you are connecting the head office to the branch office, there must be what we call a VPN. So what's the function of VPN is that anything you are sending from head office to branch office will be encrypted so that an unauthorized person won't access what is passing through the internet. So VPN is what we use to implement a security on the network. Is what we use to implement encryption on the network so that wherever you are sending from head office to branch office will be encrypted. All those bad guys won't be able to see what is passing through the network. And the second function of a VPN, VPN is used to allow some remote staff to work from home. So imagine I'm working from a Zenith Bank and I will be working from home, which means that I will be at my home and I will be accessing Zenith Bank resources. For that to be able to happen, for that to be able to work smoothly, there must be a VPN that I will be using to connect from my home to the Zenith Bank so that everything I will be accessing in a Zenith Bank network will be secure. So the basic function of a VPN is to secure wherever you are doing on the network so that they won't see everything in a plain text. VPN will be the one to encrypt all the traffic. So that's the function of a VPN. So here is a diagram of what the VPNs is like when we have head office and we have different types of branch office. Anytime you are connecting them to their head office and you are connecting your remote workers to head office, there must be VPN that you will implement in it so that everything they are doing will be encrypted. So the next thing we are moving to now here is a network devices. So when we're talking about a LAN and VLAN, what are the devices that will make use in a LAN and VLAN? The devices that will make use in a LAN and VLAN is a switch. So anytime I want to configure LAN on the network, the device I need is a switch. Anytime I want to configure VLAN on network, the device I need is a switch. So what about a WLAN? So the devices we use in a WLAN, which is a wireless local area network, the devices we make use here is a wireless access point, which is what they call a WAP, wireless access point, or you use wireless router. So anytime you want to configure WLAN on the network, you must have a WAP, which is wireless access point, or you have a wireless router. So the next one here is a WAN. So which devices do we use in a WAN? We stand from wide area network. The devices we make use in a WAN is a router. So anytime I want to connect different multiple LANs together, LAN in different locations together, there must be a router so that the router will be able to route the traffic to the other destination. So router is what we make use on a WAN. So when we're talking about a VPN, we stand from virtual private network. The devices that will make use in a VPN, anytime I want to configure VPN on a network, is either I have a router, which is a wired router. So I want you to put it in mind, there's a difference between wireless router and a wired router. So wireless router are the one that we use inside the WLAN. But when you're talking about wired router, we make use of wired router in a WAN and a VPN. So anytime you want to configure VPN on the network, it's either you have a wired router or you have a firewall appliance. So it's either you have a firewall, you can enable VPN inside your firewall, and you can as well enable your VPN inside the router. So the next thing here is a optimization. When we're talking about optimization, the devices we make use inside optimization is what they call a load balancer. So optimization is when you want the traffic to be equal and the traffic to be moving in a normal way. So for example, let's assume I hosted a website. Maybe I'm the owner of facebook.com. So let's assume I'm the owner of facebook.com. And this facebook.com, I hosted it in a 2 server. I have 2 servers on my network, and I hosted the facebook.com on the first server, and I hosted the same facebook.com on the second server. If we just leave the server like that, anytime people want to browse to facebook.com, the traffic will be going to only one server, which means that the traffic will be hitting only one server, whereas the second server will stay idle doing nothing. And if the traffic go beyond what the server should take, the server can be down. But we can use a load balancer. We can put a load balancer in between the server so that any traffic that is going to those server, load balancer will be the one to divide the traffic into 2, and one traffic will go to one server and the second traffic will go to the second server, so that the traffic will be equal, and then one server won't stay idle when another server is doing much work. So that's function of a load balancer. Load balancer will be the one to balance all traffic that is going on the network so that the 2 devices will be doing the same work on the network. So the next thing here is a storage. So the devices that will make use, when we're talking about storage aspects, the devices will make use is a server. So anytime I want to store my documents, I want to store my data, I want to store my files and resources, I can store it inside the server, or I use NAS, which is a network attached storage. So it's either you use the NAS or you make use of a server. So those are the devices that we can use to store our data and our documents. So these are everything that we're going to learn about this computer networking. So let's move to the next. So here, understanding TCP, we have covered that one in our previous class. So we have explained everything above TCP, and I can actually brief all those things for you. We are explaining everything about TCP when we are talking about the function of a TCP. And we say that inside this TCP, when we talk everything about TCP, we move to understanding an IP address. And I explained to you that we have 2 types of IP address. The first one is a public IP, where the second is a private IP. And I explained to you that a public IP address, which is what we call the external or global, this IP address is the one that we can use on the internet. The IP address that we can use global to solve the internet, those are what they call the public and IP address. And this IP address is given to us by ISP, which is an internet service provider. Example, it can be your MTN, It can be your Glo, it can be your Airtel, Etisalat. Those are the people that can give you a public and IP. But the second type of IP, which is a private IP, this type of IP is the one that we use in a local area network. Anytime we are hearing about LAN, the type of IP that we make use in a LAN, those are what they call a private IP address. All those IP addresses cannot browse the internet. They can only work within your private network. So here now says that assuming we have a public or we have a private, how can we assign IP to our system? So how can we assign IP to a system? You can assign IP to your system on the network in a two-way. The first one can be static or dynamic. So it's either you are using a static or you are using a dynamic. So if you are using a static, what does that mean? Yes, is a static IP address is an IP address that is a manually configured, where a dynamic is a automatically configured by what we call the DHCP. So we have talked all these things in our previous class, and we talk about the classes of a IPv4 address. I explained to you we have class A to E, and we say the ranges is a 1 to 126. What does that mean? Is that anytime you see a IP address that is started from these ranges, you will know that that IP belongs to class A. And this class A can only contain 16 millions of devices. We can assign class A IP to 16 million. And this class A IP, it is used in a large network. So large network, those people using class A, they are the ISP. MTN, Glo, Airtel, they are the one that make use of a class A. And here, class A has a default subnet mask of a 255.0.0.0, which is also what they call /8. And we say we have class B. So we have all the ranges and we have the number of O's. We have talked about all these things in our previous class. So we talk about all these things. We still talk about the TCP layers. Here, say we have like 4 layers, and I explained to you that the layer started from down to the top. Is not from top to down. Layer start from down to top. The first layer of a TCP/IP is a network layer. The second layer is the internet. Third layer is a transport, and the fourth layer is the application layer. So we explained all the function of all those layers in the previous class. So when we talk about OSI model, we talk about the function of a OSI model. OSI model start from a open system and interconnection. They are the ones that allow different vendors to be able to communicate. I explained to you that when there is a OSI, when there is not OSI model, there is no way devices made by different vendors can communicate. If we have a devices made by HP and we have another devices made by Mac, there's no way they can communicate because HP is not going to understand the language of a Mac, and the Mac cannot understand the language of a HP. So OSI model is the one that allow different vendors to be able to communicate. So OSI model will just stand as an interpreter in between the two connections, so that anytime Mac is talking to Windows, OSI model will be the one to translate that Mac language to Windows so that Windows will understand. So that's the function of this OSI model. And we have different layers of a OSI model. We have layer 1 of a physical. So I explained to you that layer is number from down to top. Layer is a physical, which is the layer number 1. The layer number 2 is the data link. Layer number 3, network down to application. So we have talked about all those things in our previous class. So what we'll be doing now here will be TCP/IP subnetting. So when we're talking about a subnetting, what does subnetting mean? Here says subnetting is a way of breaking down a large network address to multiple smaller network addresses. So in a scenario that we want to break down a large network address into smaller network address, that's what they call a subnetting. So for instance, when we go to classes of an IP address, I explained to you that we have class A down to class E. And I say that class A can only occupy how many hosts? Like 16 million plus. And I say the people that they make use of class A, they are the ISP, which are MTN, Glo, and Etisalat. So let's now assume that we are seeing that class A can occupy like 60 million. And all over this world now, with more than 60 million, imagine how many people that MTN are giving internet every day. We are more than 60 million and they are still be able to give people IP address. So how is that possible? That is where a subnet comes in. So subnet is when we want to break down a large network into a multiple smaller network so that we still be have a lot of IP address to assign to a computer on the network. That is what a subnetting is. So what was now the benefit of this subnetting? The first benefit is that it helps to preserve the IPv4 address space from an exhaustion. If there is no subnetting, we would have exhaust IPv4 address since. But with this subnetting helps us still to be able to be using IP address in a IPv4 address. Because inside the IPv4 address, we can take one network and we break the network down into smaller networks that we're still going to have a lot of networks on it. If there is no subnetting, we would have finished all the IP address in a IPv4. But subnetting still helps us to still be able to be making use of that IPv4 up to date now. The next one here is that it helps to minimize broadcast message on the network. If we don't have a subnet on the network, all the system will be on the same network. For instance, if we are on a LAN, system on the LAN, all the system will be on the same network. And if there's any message going to another system, there will be what we call a wide broadcast message, because the message will be sent to all the system on the network. But when we have a subnet on the network, it's going to minimize the message. This subnetting is just like when we're talking about a VLAN, which means that the traffic of a VLAN 1 cannot go to the traffic of a VLAN 2. So subnet will help us to minimize all those broadcast message. Broadcast message coming out from a VLAN 1, it can't go to VLAN 2. So subnet will help us to minimize it. So the third one says in subnet, it helps to make the network easier to manage. So with subnet, the network will be easier to manage because all the systems are not using the same network anymore. They will be using different network. So anytime I want to deny people from accessing the internet, I can use their network to deny them from accessing the internet. And anytime I want to grant access to people to have internet access, I can make use of their network. It's different from when everybody are using the same network. For instance, maybe I have like an 100 system on the network, and all those 100 PC, they are using the same network. Anytime I want to manage the network, it's not going to be easier because I will be doing it one by one. But when we have a subnetting on the network, all those 100 systems are not making use of a single network anymore. Each devices on the same VLAN will have their own network, which means that anytime I want to deny some VLAN, I will make use of their network. And anytime I want to permit some VLAN, I will make use of their network. So that's the benefit of a subnetting. So the next thing here is now the steps of a subnetting. So anytime you want to configure or anytime you want to solve a subnetting question, these are the steps that you must follow in order to achieve your goals. The first steps here says that determine the number of network and convert it to binary. So anytime someone gives you a subnetting question, these are the steps that we need to follow before we can solve that particular question. The first thing says that we should determine the number of the networks. Once we determine the number of the network, we should convert it to binary. And the second says we should reserve bits in the subnet mask and find the increment. And the third says we should use the increment to find the network ranges. So those are the steps that we need to follow anytime you want to solve a subnetting questions. So here is a subnetting question for class C. This question says your company has purchased a class address of 200 or 150.5.0 with this subnet mask of a 255.255.255.0, and you are required to break this address down into 50 different networks. So you can imagine this type of a question. A company buy a single network of IP address, which is a 200.150.5.0, and they now give you a task that you should break this address down into what? Into 50 different networks. So that means that they want to see 50 different networks with this particular address that they give you here. So they say you should break it down. So the next thing now is that before we can solve this question here, we're going to be following these steps. So we're going to be following this step to solve the question